walk you through most of the features of the language, but our focus is going to be, here's how you use this feature to accomplish this particular design strategy. Okay? The C++ language is built from the ground up to support creating value types, that is, types that can be copied and assigned and who have scope-based lifetimes. So it has all the tooling, all the mechanics necessary to do that, unlike C# and Java. C# and Java, user-defined types are reference types, live on a managed heap, have non-deterministic lifetime, and cannot be copied or assigned. You can copy and assign the handles, but you can't copy and assign the objects without going through a whole lot of work. So the C++ language gives you all the tools necessary to do that, and that turns out to be very, very effective. How many of you have not taken a course with me, class with me before? Okay, so you may be surprised, okay, at how much I expect of you. You guys are assurance, right? You're the two assurance guys? The three of you are? Okay. So we should have a conversation. Maybe, why don't you come up, can you come up to my open office hour at 2 o'clock and we can talk about that a little bit? Because you have this. So you have that special requirement. Okay. So the course is intensive. It's project-oriented. We have 4 projects and a midterm. There is no final exam, but there's a midterm that counts 1/3 of your grade and 4 projects. And the 4 projects I would expect would probably take you about 50 hours each outside of class. Maybe more. You know, your mileage may vary. It depends on your skills as a student, but I doubt that you can do it much more quickly than that. Okay, so we're going to use the C++ programming language by Bjarne Stroustrup. He was the creator of the language. Last year, we used a different text. I had used Stroustrup's book for years, and I, as an experiment, used the C++ primer by Lippmann et al., and I was unhappy with the book. The book does a nice job of discussing topics, but there's a lot of topics they don't cover at all. They say very little bit of design, and they say nothing about threads, you know. And so Stroustrup talks nicely about design, and he talks about threads, and you know, all the major parts of the language. So I've gone back to Stroustrup. There's 2 books required for the class. Guys, the class starts at 9:30. Please come on time, okay? Guys, 9:30. So the C++ programming language and the C++ standard library by Nikolai Josutis. Stroustrup is a really, it's not the easiest book in the world to read. But once you've looked at it and worried at it a little bit, what you discover is that what he told you is entirely accurate and complete. And that's not true of almost any other book. Now, the Josutis book is much more tutorial, much easier to read, doesn't cover as much, but what he does cover, he talks about really nicely. So any topic that's covered by both Josutis and Stroustrup, you probably want to read Josutis' book first. Now, strongly recommend you buy those books. Now, you know, as soon as a book hits these days, a PDF version appears somewhere. You can find PDF versions for both these books. I would recommend that you buy them. It's a better user experience to have that physical book on your desk while you're working away, because you can flip through it. Yeah, PDF, you got to search, a textbook, physical textbook, you can flip through it. So, you know, whatever you want to do is fine, but these are required books. C++reference.com is an excellent reference site. Nobody, I don't have the entire C++ language up here. I have an awful lot of it, but I don't have the entire C++ language up here, nor does Stroustrup, the creator of the language. Because it's a big language, and it's been evolving for years. So you need a good reference, and the cppreference.com is excellent reference, trustworthy. So, strongly recommend it. So there's a bunch of recommended references here. Ignore these for this semester. These are here really, this is the book we used last semester. This one, you know, is worth, if you can find a PDF of that one, it's probably worth doing because what he talks about, they talk about quite clearly. It's a more tutorial book than Stroustrup. But the rest of these, my model for you is that when you're done with this course and you want to push a little further, although I got to tell you, there isn't too much further to push because you're going to get most of everything. But or if you step out of here and start developing C++ code professionally, a lot of my students do, then these are good references to look at and get a hold of. But for now, you can ignore that. You don't need them, other than maybe finding the PDF of the Lippmann book. Prerequisites. I don't expect that you already know C++. But I do expect that you are quite comfortable with some programming language, C or Java or C#. As long as that's true, then you're prepared. Lots of people have been very successful in this course coming to it with no knowledge of C++. You'll work a little harder than those who already know some C++, but it's entirely possible to succeed without it. This is the syllabus, and I'm not going to talk about the contents other than just a really quick summary. We'll talk about the contents in a slightly different way in a few minutes. But you'll notice that each lecture page, for each lecture there is a page, and it's linked here. I don't always keep up exactly, you know, at this time schedule. Sometimes I'll get a little ahead of it. Sometimes I might fall a little behind it. That's fine. No, not a problem. But the lecture material is all there, and the projects are all linked here. So, for example, if you click on Project 1, here's a statement for Project 1. We're going to do a key value database. I've done one of these 2 years ago in software modeling analysis. And last year in this course, we did a key value database project. But this one has some different requirements. It's not the same. And I'm going to give you some starter help, quite a bit of help, which we'll talk about in just a few minutes. With that, the way my projects work, I like to have a progression of projects so that what you do in Project 1 is used in Project 2, and what you do in Project 2 is used in Project 3, and what you do in Project 3 is used in Project 4. And so you see this continuum of development, which is the way it really happens professionally. And if you get to Project 2 and you say, gee, I can't use my Project 1 here, it doesn't work well enough, there's a really good lesson there. Why wasn't it good enough for you to use in Project 2? Now, typically what will happen is I've given you some starter code that's maybe half of what you have to develop here. We'll talk about that in a few minutes. The other half I haven't given you, but as you're getting into Project 2, I might decide to give you the remaining parts, okay, if you can't use your own. But there's always, I want to see you use your own code. Okay, so, and we'll talk about this project a little more in a couple of minutes. The handout is about this helper code for that project. So this first project is due in 3 weeks. And I think it'll take you, even though I've given you a lot of help, I think it'll take you about 50 hours to do the project. 50 divided by 3. is about, what is that, about 18 hours a week? So, 3 weeks. So, maybe, but anyway, a goodly number of hours each week. So you cannot succeed in any of my classes by waiting till the weekend before a project's due and starting to work on it. If you do, weeping and wailing and gnashing of teeth. Now, I do accept projects late, but I levy a late fee of 1 point a day. So if you're 10 days late, you begin at 90 and go down from there. And I think everybody's goal should be to get in the 90s on their projects. That's going to take you to an A. And then, project 2 is due just before the midterm exam. Project 3 is due a few weeks after the exam, and then project 4, the last day of class. So the course, you'll be graded on the midterm counts 1/3 of your grade, and the projects count 2/3 of your grade, and they're weighted equally. So, all right. So let's go look at lecture 1. So for you guys who haven't taken a course with me before, you want to know this website. So let's go to, I'm running this website, I'm running those web pages off my laptop, but the same pages are on the college server. So here's the college server, and the easiest way to get that is you don't need to remember that URL. You can just come in and type in Jim Fawcett. And if you're using Google, I should be around the top, and there you are at the website. Okay? So, there's a lot of stuff on the site that we'll want to use. I'll get back to that in a minute. One other thing is we're going to use Piazza for this course. Most of you should have gotten an email from Piazza. Some of you have gotten raise your hand if you've gotten an email from Piazza. Okay, most of you have. If you haven't, see this handsome fellow sitting in the back corner? Stand up, Amar. Stand up and smile. So that's Amar Salomon. He's the chief honcho TA. There will be more TAs, but he's the leader of the bunch. You can see him, and he'll help you get. First of all, just go to Piazza. You just type in Piazza, Piazza, and that'll take you to the site and see if you can. They can log in themselves. Can they? Do you remember, Amar?
Yeah, the link goes to everybody, and that's like an.
Well, see, the email goes to I set up Piazza 2 weeks ago, so anybody who registered after that didn't get added.
They can look it up by the number of the course.
Yeah, they can look at it, but can they then enroll themselves?
Yeah.
Okay, so you can enroll yourself. If you can't figure out how, go talk to Omar. But you should be able to. Now, what we use Piazza for is as a question and answer board. So, you pose a question, and another student can answer it, but I ask the TAs to look at it once a day, and I look at it a couple of times a week, and if a student answers it and the answer isn't quite right, we'll gently correct that answer. But I welcome Wei Heng has contributed sometimes, with an answer to a question, right? Maybe it wasn't you. I was thinking it was you. But anyway, one student can answer another student's question. So you get answers really quickly, and the TAs look at it often enough so that if the answer isn't quite right, it'll gently get corrected. We don't blame anybody. We don't say, "Oh, that answer was stupid." We don't do that, but we might make a minor correction to, just so you know you're getting the good stuff. So use Piazza. One of the reasons for us using Piazza is that I welcome questions during the lectures, but I use a fire hose technique. A lot of stuff is coming at you. And so it gets kind of hard to get a question in edgewise because I'm talking so much, blah, 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 coming at you. So if you don't get it, then you can post it on Piazza. Also, every Friday morning, starting at 9 o'clock in this room, I have a help session. I don't come with an agenda. I'm just here to answer your questions, and usually they're very productive sessions. We can talk about things in a relaxed way, and get you more details. Okay. So if you go to the home menu, all of these drop downs are appropriate for all the courses. But if you go to the individual lecture page, these menus are mostly just for this course. So if you go to lectures, here's each one of the lectures in this course. So if you want to find, where do we start talking about sockets? Right here. So you click on SOCKS 1 and away you go. The projects are all listed here. So here's the project 1 description. By the way, when we look at that, you'll see that the project has some requirements. Shall. What those shalls mean is that you have to demonstrate that you met that requirement. There are right now about 165 students registered for this class, and we don't have nearly enough TAs to spend an hour apiece grading your projects. So we require you to demonstrate that you met each requirement. So the TAs just start your program, sit there with their hands behind their back, blip, 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 comes your demonstration that you met those requirements. And I'm going to show you this morning what that really means. So each of these shalls are just stuff you're going to do. Stuff you're going to do and demonstrate. Now, by the way, if you haven't met, the due date is coming and you haven't met every single requirement, you have a choice. Do I submit without meeting every single requirement? And you can. Or do I continue working on it and submit late and get a 1 point a day late fee? My recommendation to you is that you submit on time. For a couple of reasons. One is that it might well be that you'll lose more points by being late than you gain by adding the additional requirements. The second point is that when you work professionally, you're expected to turn in stuff on time. So it's a really good idea to get in the habit of meeting your deadlines. So strongly recommended that you do. But again, we will accept them. So each of the projects are here. So there's a videos link, and that's going to disappear because there's a new SU policy that says we're not allowed to have any videos that are not captioned on an SU website, and we can't link to videos that aren't captioned on a SU website. So that means that I used to have videos, I post videos all the time on that video page for each class. Not going to happen anymore. Policy forbids that. Somebody who was hard of hearing threatened to sue the university because their videos weren't accessible. It is fun to do. But please, from now on, the class starts at 9:30, so come on time. So I won't put them up. Now, if I can figure a way to do it, I'm going to still record them. If I can figure out a way to put them on YouTube or something, and in a reasonable amount of time, I will do that, and I will give you the non-clickable link that shows you the URL to get to them. Okay, and so I'll barely satisfy the requirement because I'm not allowed to link to. So, but no promises. So I think you should assume that there won't be videos for these courses. If I can, I will, but the videos for software modeling analysis will stay up at least for a while, but so you can't depend on those. That means you got to come to class. That's a good thing. There's some more advice about, we'll look at some of this stuff, how do you upload projects and what are the requirements for submission, what's our grading policy. As we get a little closer to the due date, we'll talk about some of those things. Code snaps are some code that is webified, just appears on this web page as a web page. So most of the code for the course, I have lots of samples, and you will download them and pull them up in Visual Studio and run them. But a few pieces of code that illustrate really important things, I put up as webified code. And so they're immediately accessible. So, you want to, what's the syntax for a template? Click on one of those, down it comes so you can see immediately. So these code snaps are here, and so you see I have pointers and references. Lots of people when they start C++ aren't really comfortable with pointers and references, so this is just some demos that help you with that. You will need to be comfortable with pointers and references. There are lots of ways to shoot yourself in the foot with pointers, but there are lots of ways to make sure that they're used safely, and I'm going to show you exactly how to do that by example and by, I'll talk about it and then I'll show you by example. It's really easy to do. The language gives you all the features necessary to use them very safely. So we'll do that. Anyway, bunch of stuff there. Notes. The notes are things that encapsulate some small important thing. Classes, class relationships, inheritance, compound objects, templates. So you'll discover as we look at the, we're going to take a quick look at some of the prototype code for Project One I've handed out. It uses templates. And you say, but we haven't talked about templates. And in fact, we won't talk about templates until just before Project One is due. But there's there's two parts to templates, an easy part and the hard part. And all we need for Project One is the easy part. We don't need any of the hard stuff. So what you'll discover is that between looking at my prototype code and looking at this templates, here's some example code and a little bit of discussion. That's all you need. So you'll look ahead a little bit. So these notes will be useful. I want to stop and just take a quick look at this course summary. So this course summary is, in fact, a summary of what we're going to cover in the course. C++ language, and again, I am not going to teach you the C++ language. I'm going to illustrate almost all its important parts, but you are going to teach it to yourself. You don't already know. And even if you think you know, you'll know a lot more, okay, by the time we're done. Threads, we're going to write multi-threaded program. Sockets, we're going to use sockets to build communication channels. So we're going to build a message passing communication channel, and we're going to use sockets to do that. Okay. I have a sockets library that'll help you a lot. And there's a lot of helper code for some of this. There's a lot of helper code for the communication channel. Graphical user interfaces, we're going to build some. The C++ language has a very effective standard library, very well designed, well engineered, really useful, but it has some surprising omissions. It provides no help in building graphical user interfaces. And the frameworks that support building graphical user interfaces fall into two camps. The not very good, clumsy, hard to use camp, or the very good but very hard to use camp, like OpenGL. Open Graphics Language is a great library. You know, you can do lots of wonderful stuff, but it's hard to use. It's really big. So C# and the .NET framework has this beautifully designed Windows Presentation Foundation, and we're going to use that. So we're going to take a little tiny excursion, do a little bit of C# to build graphical user interfaces. But we need to make that interoperate with C++, and you can, and I'm going to show you exactly how to do that. So Project 3, I'm going to give you an awful lot of help with the communication channel. Project 3 will focus on building a channel and a graphical user interface. So what's happening in these projects is Project 1 starts out with a NoSQL database. Project 2, we're going to build a full-up repository with check-in, check-out, versioning, browsing, you know, all the good stuff. And we're going to use the NoSQL database to hold all that information. The repository will hold files and directories, but all the information about what's there, you know, what do you have, what are their characteristics, will be held in this NoSQL database. And then in Project 3, so that's just a local repository. In Project 3, we're going to get ready to make a remote repository by building a message passing communication channel using sockets and a graphical user interface. And then in Project 4, we buckle it all together to build a graphical client that talks to a remote repository. That's where we're going with projects. So we, you know, that's why we need what we need. And if you click on any of these, so if you click on C++ language, here it drops down a whole bunch of stuff. So historical context, yeah, okay, here's a diagram that shows the family tree, the language family tree for C++. So here's C++, created in 1988, and it started a little earlier, but the first public compiler was available in 1988. It grew out of Algol and C. Algol is a European language developed mostly by the French, I think, was used in a lot of scientific programming. Still used a little bit. And so on. But classes, so here's a little description of class. A class is a language construct that binds together member functions and data, providing access to users only to the member functions, not to its data. So that allows a class to make a strong guarantee about the integrity of its data, because another program can't come along and mess it up, because you can only interact with it through the member data, through the member function, and the member function should be designed so that any use of them can't put the data in an invalid state. Okay, so each one of these, you know, just a little capsule statement and then some links into, you know, lecture 1 page, cppreference.com, and here, classes. So this takes you to that, you know, a little class page that says, you know, here's the anatomy of a class, and here's all the parts, and we are going to, in lecture 4, we're going to pull apart all of these various standard member functions. So these member functions, what endow value type behavior on a C++ user-defined type. Copy constructor, assignment operator, so on. And we're going to go through that in gory detail in lecture 4. You're going to see exactly how to do all that stuff. Um, you know, rule of three, abstract data types, templates. So here maybe you want to, little discussion of templates, and here's a template example, some example code you can look at, and blah, 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 blah. I think there's a code snack for stacks. There isn't, but I'll put one up. So, and, class relationships discussion, there's 4 relationships between classes: inheritance, composition, aggregation, using, and there's diagrams associated with it. You can click on the diagrams and bring them up and look at them. We'll be talking about all this sort of stuff. So the model of this is that this is like a quick entry point into the various things we're going to talk about in the class. So it helps you understand what's the flow of what we're going to talk about. And if you need to look ahead, like we need in project 1, you need to look ahead on templates a little bit. Let you do a little bit of gentle exploration to pick up whatever you need to know. And it's also good as a review for the midterm exam. And it's also good when you're going to interview. You want to review stuff. Nice thing to do. So, C++ language, and threads, discussion of threads, sockets, discussion of sockets, graphical user interfaces. I talk about a little bit about that. Standard libraries. So this isn't all of them, but they're the most important ones. The C++ standard library, as I started to say when we were talking about graphical user interfaces, very well designed, very well engineered, but it has some surprising omissions. It has no ability, supports no building of graphical user interfaces. And also, it provides no support for getting directory information. If you know a file exists, you can open it using the standard library. You can create a new file, but you can't go to a directory and say, what do you hold? So I built a library to help you do that. I'll talk just very briefly about that in a minute. So you'll discover that the libraries are very well designed, quite easy to use, but have some omissions, but the omissions are fairly easy to fix up. Here's some custom libraries. So here's a file system that I wrote that uses the Windows API to explore directories and do path manipulations and stuff. Socket library that I wrote that supports both IP4 and IP6. C++ properties is a little example of what you can do. C++ doesn't have properties like Java and C# do. C++ doesn't, but you can build your own if you want. So, and I show you how. There's we need to when we build even for project 1, we're going to need to do a little XML because in project 1 the database has to be persisted, has to be saved. We're going to save it to XML, and so there's a XML document library that I provided that lets you do that in a quite simple way. Okay. And there's a study guide, OD study guide, and the good news is, boy, there's links to all kinds of stuff. The bad news is, oh boy, there's links to all kinds of stuff. So, we're gonna, you'll be comfortable with most of all this stuff by the time we're done. And in order to get there, we need to work really hard. I'm going to work hard, and you're going to work hard. Okay, so that's where we're going with this course. Okay, so here we are back at lecture one. So there is a C++ survival guide that I wrote that is just a little summary of syntax for pointers and references, for classes, class relationships, standard strings, IO streams, file streams, string streams, iterators, and vectors. So these are the parts that you'll use mostly. And so this is just a little syntax, little cheat sheet for the syntax to help you get started. So probably a good idea to print it out, put it on your desk, under your elbow when you're writing code for the projects, and there it is. You can look stuff up quickly. How do I do? Okay, so syllabus we talked about, course summary we just finished. So here's project one. So let's come back to this just for a minute. So project one, again, last year's class did a NoSQL database. It's not quite the same as this one. The requirements are different. They share some requirements, but they're different. I've given you some helper code, and the helper code satisfies that requirement. And that's the core part. What the helper code doesn't do is give you any way to query the database. All the helper code will do is let you see its contents by using each of the keys. You can get the key collection, and you can look at each key and click, 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 click. But you don't want to do that. You want to make a query. Show me all the stuff that satisfies these conditions. Bam! You're going to write that. You're going to write a query part. I'll have some suggestions. Not immediately, but fairly soon I'll have some suggestions on how you do that. And you have to write the persistence part. And the persistence isn't just save the whole database. The persistence says save all the files in some category. So you're going to provide the capability to shard out the database into different parts, different files, if you want. It's called sharding, a standard database term for taking part of the database and persisting part of the database someplace. So you're going to write the editing, you're going to write querying, you're going to write persistence, and you have to demonstrate that you meet all of the requirements. So let's pull up. Let me show you what that means. So here's the prototype code. So, if you look at the sheet, the handout, you'll see, okay, there's a DB core, sure enough, DB core. There's a date time, sure enough, date time. And if we run it, demonstrating requirement 1, demonstrating requirement 2, demonstrating requirement 3A, demonstrating requirement 3B. And these have to be real demonstrations. So for example, when you get to editing, you need to show, if you're going to demonstrate that you can edit an element, you need to show the element before it was edited, and then say, now I'm going to, and then here's the element after editing. That's the thing you have to do. And, you can use, this is a little IO that I wrote. You can use that IO to illustrate your database. So here I am demonstrating, the first one says, the first requirement was that you've written this using C++ 11. So I took a construct that only compiles under C++ 11 and put it into my test. And I said, see? So here's this function, bool, C decal void. It doesn't matter what that means. You don't know what that means now, but you will fairly quickly. But this is something that was only available since C++11, so it couldn't possibly be there if it wasn't written in C++. Concrete proof, passed using C++. And demonstrating requirement 2. So here, requirement 2 says that you're only going to use streams and new and delete. You're not going to use standard. You're not going to use standard I/O, the CIO, and you're not going to use malloc and free. Now that would be really hard to prove that you haven't used it. You'd have to do an exhaustive search for a whole bunch of things. So here I say visual examination of all the submitted code will show only use of streams and operators for new and delete, passed. But except for a requirement like that, you need to really demonstrate you met everyone. I've had students submit code that didn't work, but pretended to work. That manufactured output that looked like it was coming from the real thing. Okay. And they worked harder to generate that output than they would have to build the darn project correctly in the beginning. Okay. So these tests have, darn well better show that you really did it. Okay. So that's the model. Every single one of those shalls, every shall, demonstrate, demonstrate, demonstrate. And so the TAs, there's 100, and right now 160 some students in this class, and we don't have enough TAs to spend an hour apiece looking at your project. So you have to demonstrate you meet the requirements. So what they'll do is they'll run it with their hands behind their back, and when your program is done running, it demonstrated you met all the requirements, and anyone that didn't demonstrate, X on that requirement sheet. Now, when I hand back the projects, that following Friday, we have a grievance session where you can come to the TA who graded your project and say, this is wrong, I implemented that. And the TA will say to you, show me where in the output it demonstrates you implemented that. And you'll say, well, I didn't write any output, no points, nothing back. Okay, no correction. You're obligated to demonstrate you meet every requirement. That's a professional, same kind of thing. When you work professionally, you're obligated to demonstrate that your code works. To be a design review, and you darn well better prove that your code works at a design review. Well, there's a design review and an implementation review, but an implementation review, you got to demonstrate it works. So now let's pull up the sheet I handed out and take a little bit of a look at it. So let's go back to lecture 1. And if we come down here to projects, here's the prototype class diagram. So DB core wraps a standard unordered map. And what that is a hash table. For you guys that know C# or Java, it's a dictionary, key value pair store. But it's based on a hash table, meaning that the key to find something, the key is given to a hash function that computes an address in a table where you'll find that element stored. There's a bucket of a hash function isn't guaranteed. If 2 keys are unique, it's not guaranteed that the address will be unique. So you might have more than one. So what happens is that a hash table has what's called a bucket, which is just a linked list of all the elements that map to that key. So anyway, it's essentially constant time. The time it takes to compute the address from the hash, essentially constant time. So no matter how big the store gets, it's essentially constant time lookup. That's cool. And that unordered map is a NoSQL database. It is. All DB Core does is wrap it a little bit to give it a database wrapper. So it looks like it's easier to use than the unordered map directly. It focuses you on what we're doing. So what we have a datetime object. We have a child collection which represents dependencies. So in our repository, when you use your NoSQL database in Project 2, this T is the payload. This will be a fully qualified file name. We're not going to save files in the database. The directories do a nice job of that, but we're going to save information about the files. Where are they, and other information about them. Who's the author? When were they submitted to the database, and so on. We're going to include that in this other data. And especially, what is its dependencies? I want to be able to go to the repository and say, give me that element and get back that element and everything it depends on. So I don't have to remember all those things it depends on. So we have a child collection, and this child collection is just a set of keys. And so that key gets to the element of the file that this file depends on. And there's a date time, there's a couple of, there's a name, metadata. I haven't shown all of them, but basically this is the model. So so the prototype code defines a database element, and it defines this core, which is a wrapper around a standard map, a dictionary. Now, one reason we use the T is that from application to application, the kinds of things we want to store in the database, the real thing, T represents the real thing I want to store. For the repository, it's a fully qualified path name, file name. Maybe it's a little more, because we probably want to store categories. For a professional project, there might be several thousand packages in a professional project. How do you find them in a repository? You need to divide it up somehow, and that's what categories are all about. So these are display files. These are signal processor files. These are user interface files. Okay. Those are the categories. So we will store in this T will become an object that holds the string file name, fully qualified file name, and a set of categories. Probably a little vector of categories, something simple, some little simple code. Now, this stuff over here is what does that requirement 1, requirement 2, requirement 3, requirement 4. Each test, every time we want to run a test, that test should run in the context of a try-catch block. If you don't know what that is, look it up. Okay? I'll talk about exceptions sometime later on, but it's, you'll see it in my code long before I talk about it, and my talking about it will just, is intended to give you the fine details about it. So go look it up. But it's essentially an error handling mechanism, and I think most of you know what an exception is. So each test, what you want is, if an exception is thrown, you don't want all your testing to stop. If there's 43 tests, I don't want it to test the first 3 and then bang, an exception thrown and it doesn't test anymore. I want to test 1, 2, 3 exceptions thrown, 4, 5, 6 down to all 40. I want them to all run. So we run every test in the context of a try-catch block. But it's a real pain to write those 43 try-catch blocks. I only want to write it once. That's what this does. So test executor runs a single test in the context of a try-catch block. And then test exec has a collection, which I haven't shown here, but it has a collection of tests. And it just steps through those tests, running each one of them in this guy's try-catch exception mechanism, environment. And this test string is what we mean by a test. And what this is a name or a phrase, and then a callable object, something that can be invoked that returns a Boolean, takes no arguments and returns a Boolean, passed or failed. Okay, and when we talk about the code, we'll look at that a little more. But basically, so that's what this is. So here, there's a date-time class. So one of the things the standard library provides you, it does provide some time handling information in a library called Chrono, but it's notoriously hard to use. The time it's simple stuff. Why are you making it so hard? So I wrote a little datetime class that makes it easy. I can say datetime.now and it'll return a string for the current clock time. Bam, there it is. dbCore, this is a wrapper around the dictionary, the unordered map. So let's just go look at dbCore.h. Looking at it, so here's my dbCore class, and here's my database store, and what that is, database store is just this unordered map of key DB element. Yeah. So I don't know all the details. I don't know how to write that code yet, but it makes sense. Part of my job, a big part of my job, is to give you the mental model. When you write C++ code, you need an approximation to the compiler in your head. C++ compiler. I need to get this to happen. What kind of statement makes that happen? What's the compiler going to do to that code? So none of us have a perfect model, but my job is to give you a pretty darn good one. And you will. All you got to do is work hard. And these usings are just a way of taking some long thing and making it a nice short, So this unordered map of key data, is this the database or is this something else that I'm doing? Oh, this is the database, DB store. Okay? So those these are type aliases. You can't make an alias to a function, not this way anyway, but this is a type alias. So, and here is the test utilities. So here's the test utilities.h. Notice that my packages all start out with a prologue and a quick statement about what it does. Provides single user test harness. And this package provides classes test executor and test executive. Tells you a little bit about what they do, what are the required files, maintenance history, and then the code. And you're expected, when you submit code, it's expected to look like this. So you're expected to have prologues. You're expected to write readable, understandable code. And that comes in two ways. It comes by writing code. So the code itself is really clear by the names you wrote, the names you use, and the simplicity of your structures. Really clear what they do. And then comments that help you quickly, before you dive into the code, understand what you got. So here's the test executor. We'll execute, and it's going to run this test T. And notice that this is a template. So this says, I don't know what this type is yet. This might be a function pointer, a pointer to a function that takes no arguments and returns bool, or it might be a pointer to something called a functor, which is an instance of a class that is callable the same way, or it might be a lambda, which is a quick local function you can define. Okay, they're all different types, but they all have the same effect. You call them with no arguments and it returns a bool. And so this is what using a template allows us to do. This is the easy part of templates. All you got to do. So it's just like generics in Java and C#, only better, for reasons we'll talk about when we get to templates. Okay. So, so now I just execute that function or callable object, whatever it is, function pointer, functor, lambda, doesn't matter. And the check just checks to see if it's passed or not, does a little IO. And here is the execute function. So notice that there is a try-catch block. So here's try. Here's where I'm executing that T. Here's T. I'm executing it. It takes no arguments and returns a bool. And now I check the result. And what this does is if it returned false, it just prints out the test failed and gives you the name that you supplied, you know, the little phrase that you supplied in the test. And so if it doesn't throw an exception, it does a runs a test, displays its whether it's pass status, and then returns the result, true or false. If it's an exception, what it does is it displays that it's false and then returns. So even though an exception was thrown, the exception is caught, the fact that it's an error was displayed, and then it returns. So occasionally, an exception is not an error. Suppose I was testing some error handling. The error handling is going to should throw an exception. So if I don't throw an exception, that's an error. Right? But that's a topic for another day. Okay. So, and here's the, the check is just saying, if the result is true, write out passed. If the result is false. So, I don't have to keep writing that little tooling. I just do it once, there it is. And then every test just does that. Here's the test executive class. And so I say, now this standard function is something we'll talk about. I'm not going to talk about it today, but I'll talk about it real soon. Do tests, register test. So register test is just a way for me to add a test to this guy's collection. Remember that this guy is holding here's a tests equals standard vector of this test structure, and the test structure is just a test and a name. And then I register that, I add that test to the collection, and then when I execute, all I'm doing is saying, for each of those tests in this collection, execute. So now it's running in the context of a try-catch block, and we'll report whether it's true or false. Cool. So, and for the prototype, so here's the database. So this database just is a little he said, she said. So you'll notice that I and all the TAs have a record. So there's a record for Amar. Okay. So here's Amar's record. Amar, TA for 687. And child keys are Sun, Pressure, Aurora, and Janapa. I think these are going to be my TAs. The department hasn't told me yet. I don't know. So on my record, Amar and those other guys are my children, the people I depend on. Now, Amar is the chief TA, okay? He's a little more equal among equals, okay? And so his children are the other TAs. Nicely recorded. I'm illustrating that dependency structure. And so here is the date time. Here is the name. There's a string description for each element. So if I want to describe what this file is doing, I can put it in a description. So in project 2, you're going to write some browsing that lets you step through each of the files and see what they're doing. Okay, and the payload is just, so here, the instructor, I am saying the good news is, the bad news is, you've all heard, most of you, if you've taken a course with me before, you've heard that before. You already heard it once this morning as I went through all those. The good news is there's lots of code for you to look at. The bad news is there's lots of code for you to look at. So, and Akash is saying, you didn't demonstrate requirement 6. And Amara is saying, you should try, and so on. That's the model. Little demo database to kind of pulling you into the way the class works, as well as demonstrating what you got to do for project 1. Okay, so my goal, I did this for a reason. So I have this project statement, which is an interesting project, does something useful. We're going to discover that we can create a database that is persistent, that is queryable, that can have stored procedures, and that for which we can create indexes, all the things you do with a major database, and we can do that in 3 weeks of work. Piece of cake. Well, maybe not a piece of cake, but not all that hard, especially with the help I've given you. So I did what I think is half the project. And I did that on purpose. There's 2 purposes. The one purpose is that you can pull that down, look at the code, and see what you don't understand, and it gives you a tangible thing to go look at, or go to the TA, or come and talk to me. What does this mean? Something tangible. It isn't just, I don't know what's going on. What does this thing mean? Help me. But better, it says when you see that template, what does that mean? You go to the notes, look at templates, read it for yourself, and probably you'll answer your own question. And those are the best. That's the best thing that can happen when you answer your own question. The other reason for me to do this is that we did a similar project last year, and I don't want you just to go to your seniors and say, give me a copy of your exam. You change the name and submit it. Because there is a core and different requirements, okay, we'll spot that immediately. All the TAs and I will be looking, is this last year's project or is this year's project? If it's last year's project, 20, 30, or out of 100, something like that. If you use this core and build on it a little bit, even if you don't meet all the requirements, you're way above that. You're in the 80, 90 range. So it's here. I won't give you this much help. I will give you help for each of the projects, but I won't give you this much help. This is just the first time. While you're struggling to get your arms around this big language, you have lots of tools on the website, and you have this code to look at. Get your arms around. Okay. And Piazza, you can ask questions on Piazza. And okay. What time do we end? 50. And what?
50.
10:50? Good. Okay. So I'm about on target here. So, I'm not going to go through this code anymore. I invite you. I will have a help session this Friday. So every Friday morning, almost every Friday morning in the semester, I have a help session in this room that starts at 9 o'clock and typically goes until about 11. And I don't have an agenda. I just come and answer questions. I'll get up at the whiteboard and I'll write stuff, and we'll pull up a presentation or pull up requirements and talk about them and stuff. So you're invited to. So that's a nice, casual, Here, there's so much coming at you, it's hard to get a question in edgewise, okay? But there, on the Friday morning help session, it's easy to get your questions answered. Talking about getting your questions answered, there's an office hours page, but I have not updated this. This is last fall's office hours because the department hasn't told me yet who my TAs are, who my support creators and TAs are. And so as soon as I know, probably by this weekend, I'll bring this up to date. And there will be typically 2 hours twice a week. So 2 of the TAs come to 1 2-hour session, maybe on Tuesday, and 2 TAs come to the other help session, 2-hour help session, maybe on Friday, something like that. And so, you know, everybody should get their questions answered. You can also ask questions on Piazza. You can come to my open office hour and ask questions. You can't ask in class, it's just hard to get, because we have so much to cover, it's hard to get good answers. So this will get updated, and every lecture, the menu, you know, office hour is always part of that. And there's a blog that has a bunch of things here that may be more or less appropriate for this class. There's a NoSQL database blog, but I'm going to change this. I wrote this to give some help for a software modeling and analysis class when we're writing the NoSQL database in C#. And the language constraints are such that it's easier to write in C++. And you can make it more direct and simpler in C++. And so I'm going to change that blog. This blog is really focused on the C#, Java, C# kind of development. And I will change it a little bit to look more like this. Okay. But anyway, the blog is there to help you with stuff. Some of these will take you away from this lecture level to different parts of the website. If you ever get confused and don't know where you are, every menu has a site map on it, and you can always come and on the site map, click on 687 lectures, that'll take you to the first lecture. And then if you want to get to some other lecture, just pull down and go to whatever, you know, whatever lecture you want to get to. Okay. So, syllabus, which tells you when all the projects are due, and the projects have due dates on them as well. And with luck, what I say on the syllabus is the same as what I say on the project statement. If you detect that they are different, please contact me right away, and I will make them the same. Okay, I don't want ambiguity about when it's due. One other thing, just a little caveat. I have with each class, I've had a repository. This is ordered in. Oh, I gotta be in the code. So I have a repository. Right here, which I use to put, I don't have it on this machine. It's on the college server. There's a repository for each of the classes, but I've had a continuing problem. My configuration management is awful. And so it's not unusual for me to put a demo someplace and you to find an older version of the demo, you know, and I fixed a bug or two in the demo. So I do 2 things. One is in every project you'll find in the code section a project 1. So you'll find, and this is, let me go to the college server so you see it just the way you'll see it. So if we go down here to courses, 687, lectures, we go to directories, so here's 687. So you'll find here's the repository for this code, but you'll also find if you go into the code, you'll find a project 1 help spring 18. And sure enough, is a CPP NoSQL database prototype. Project 1 help spring 18. And when we start thinking about Project 2, there isn't one now, but I will create a folder called Project 2 help spring 18, and anything that's important I'll put there. Now, because I have, in fact, this code, this NoSQL database resides in 3 different places the college server. Not good. So I am going to create the folder actually exists, a repository folder at the top levels, SU level, this handouts level, repository, and I will make all the others link. So there'll only be one copy, and I'll use hard links or symbolic links to get to that. That's the right way to do it. I should have done that years ago, but I'll be putting that in place. So you may find that, some links don't work right because I'm in the, I didn't get it all right yet. Okay, but I promise you that the latest version you will get directly to. The last symbolic link I'll put in is a symbolic link in the Project 1 help and Project 2 help folders until I've got that all up and working, so I'm sure that all the links work correctly. The real code that I want you to use will be in these Project help folders. And they will, I promise you, they'll be with a 99% reliability that they'll be the latest version. But you'll have to bear with me because I'm going to be fiddling around with links for a while. And I've got so much stuff to link and clean up that it'll take me a little while. Okay. We said we'd go to 10:50? Okay, good. I got 6 more minutes. So, okay. So, each lecture has a lecture page. I don't, so let's go to the syllabus for a minute. They're all laid out with dates, but sometimes I get a little ahead or fall a little behind, and that's okay. Not a problem. But, I won't change this, but, what will happen is we might be behind for a couple of weeks, and then I'll catch up, and then we might get ahead for a week or two, and, so, but these are all based on content, and these links all go to the project due. We will accept projects after the due date with a penalty of 1 point a day. Except for the last project, Project 4, is a 5 point a day penalty. The reason for that is I have to get my grades in really quickly after the semester's over, and I have to have a forcing function to force you to get the projects in. So that's what I do. Midterm, yeah. So I don't think I mentioned this to you before, so let's go look at it right now. Just quickly. You'll find my solutions to the midterm. So here is a midterm 1 instructor solution 17. And so I didn't want to pull up the. So, here's the question, my answer. Question, my answer. Question, my answer. Some code. We will write code, by the way, on the. So probably a good idea for you to go and look at some of these midterms. Not to digest the material there, but just to see where are we going and what kind of things you're going to be held responsible for in the midterm, so you know what to focus on as we make that progress getting toward the midterm. The midterm will happen about 2/3 of the way through the course. We will have gotten most of the major content in, and then it's just gravy after the midterm, okay? So, there's some interesting stuff we're going to talk about. So I think you should, maybe this weekend, look at them. You'll notice that there's 4 midterms and they're all different. And the reason is that both sections are packed, just like this section is packed. And, we're all honest people, but I don't want to strain your integrity to the breaking point. So here you are sitting, it's so tempting to, so I hand out, at this class, it'll be exam 3, 4, 3, 4, 3, 4, 3, 4. And they aren't just the same questions shuffled around, they're different questions. And the distance between midterm 3 and midterm 4 will be the same as the distance between midterm 3 this year and midterm 4 last year. Same distance. So you're getting a lot of help by looking at those past midterms. And and there's 4, because in the morning session I gave 1, 2, 1, 2, 1, 2, 1, 2. And so, there's no point in you run out, to the people who just got out, what was on the midterm? Because it's a different exam. All right, any questions about what this is, where we're going? So I think what you want to do is you want to take a look ahead. I will often put, so looking ahead, you want to take a look ahead. We're going to talk about some of these things on Thursday, okay? So you want to take a look ahead a little bit. I don't mean to study it, but for example, you might take a quick peek at some of the stuff. You want to definitely take a look at the project statements, especially look at the project code, the helper code, and Friday morning help session, open office hours I hold on Tuesday and Thursday starting at 2 o'clock for 1 hour. And the TAs next week will be holding office hours. Any final questions before we break? Going once, going twice, we're broken. Handouts are still here. If anybody didn't get one, come and pick one up.
周一只有周一晚上。有去了。我想选，你选吗？第一呢，你要把那个在这个杨楚云。
为什么？你不是也上这种课吗？你选的是8点，我选的是9点。你是哇，你有这么多时间。